So today we will be moving on with dividing decimals. This time our result is going to end in a decimal. So it's getting a little harder than last time. So we will find quotients that are not whole numbers. So I started you out with a little bit of a review. And I just want to point out these couple things on the next two slides. So when you have the fraction 3 over 4, what you need to know is, technically speaking, that fraction sign is a division sign. So what you need to memorize is the denominator, the bottom number, always goes on the outside of the house. So this little guy here, I call that the house, right? And one is in, one is out. The bottom number is always on the outside. It doesn't matter how big the number is. That can say 3/10, that can say total different numbers. And no matter what, the bottom number is always on the outside of the house. Now, the other important thing to know is that the top number, that is always going to be on the inside of the house. And it doesn't matter what the number is. It will always be this way. So even as an adult, when I see a fraction that I need to make a division problem, I still do this. I remember this from elementary school. So these are things that you need to know, and it will be expected that you know this as we continue on. So I kind of set you up with two separate problems that look very similar, but they're not. They're two completely different problems. But these are very common misconceptions with kids. Okay, so this reads 5 divided by 10. This reads 10 divided by 5. So they're two different problems, and their order matters, right? So what you would do is, if you have 5 divided by 10, that technically is 5 over 10, right? So that division sign, remember I told you, that fraction sign, they're equal. They mean the same thing. And then if you look at the next problem, 10 divided by 5, you would write 10 over 5, right? And remember that that division sign is the same as the fraction sign. So now we're going to kind of work these out. Okay, so remember that I told you when you're dealing with the house, right? The outside number, or the bottom number, is always the outside number, and the top number is always inside. So look at how I set you up below. And then if you look at this one, this is on the outside of the house, and this one's on the inside of the house, and I set you up below. Very important things to know the difference between the two. So on the first one, this one's a little harder. 10 does not go into 5. So what we need to do is we need to add a decimal, and we need to bring that decimal above, and we need to add a 0. Now 10 can go in. Well, 10 isn't going into 5. 10 is going into 50 5 times. Now, based on me putting it into 50, it's going to be to the right of the decimal. Okay, so now 5 times 10, that's just 50. And you get 0. Okay, so your answer here is 0.50 or 0.5. Now, if you look on the one to the right, this is what you're used to in elementary school. 5 goes into 10 twice. 2 times 5 is 10. Subtract, and you get 0. Okay, so two very different problems with very different answers, and it matters the way that you set it up. Now, today's focus is going to be right there. We're going to be focusing on the harder of them because our answer needs to be a decimal. That's the topic. So you're on page 72 in your book, and we're doing number 3, and you're at the bottom of page 72. 4 students share a $271 prize from a science competition. How much does each student get? So the 4 is important, and the cost, right? Or the money. So how much do they get? So I set you up below. So you're just in your book, page 72, and you're following along. Now, if we were in the classroom and I was setting these up on the whiteboard, I would be setting up this imaginary line, right? And that's that green line that you're going to keep seeing. And what happens is that is where your decimal is going to go. Currently, that is where the decimal sits in the problem. And we're going to kind of work these out, right? So 4 does not go into 2. But it does go into 27 and it goes 6 times. So take note that this is above the 7. It's not above the 2 because I did it into 27. Okay, so you get 24. You subtract and you get 3. Well, 4 doesn't go into 3, so we bring down this 1. Well, 4 goes into 31 7 times. So 7 times 4 is 28. We subtract and we get 3. Well, 4 doesn't go into 3, and we cannot leave it like that. We no longer leave it as remainder 3. That is the old stuff. We need to keep going. So what we do is the decimals here, we move it up to the top and we add a 0. And that way we can bring down the 0. So 4 goes into 37 times. Notice how I'm above the 0. I'm to the right of the decimal. 4 times 7, is 28. And I end up with 2. Well, 4 doesn't go into 2. So I add a 0 and I bring it down. Well, 4 does go into 20 5 times evenly. 5 times 4 is 20. And you get a 0. So your answer is 67.75. Okay, so that's that one. So now you're going to move on, and we're going to be calculating more of these. So page 73 at the bottom, we will use long division to find each of these. So I set it up on a new page, but you're still on page 73, and we are doing 2A. So we'll start. 8 does not go into 1, but it goes into 12 one time. 1 times 8 is 8. Notice how it's above the 2. It's not above the 1 because I did 8 into 12, not 8 into 1. Okay, and then when I subtract, I get a 4. And then I need to bring down my 6. Well, 8 goes into 46 5 times. 5 times 8 is 40. We subtract and we get 6. Well, I'm not done. 6, I can't have a remainder. I need to keep going. Okay, so I'm going to put my decimal here, and then I'm going to bring it to the top so it's in the answer. And I put my 0, I bring it down. Well, 8 goes into 60 7 times. 7 times 8 is 56. And I subtract and I get 4. Well, 8 doesn't go into 4, so I add a 0 and I bring it down. And I have a 0. Well, it evenly goes in. 8 goes into 40 5 times. 5 times 8 is 40. I subtract and I get 0. So your answer is 15.75. Please make sure that you're writing these down. Please make sure that you are working them out for your notes, for points, okay? All right, so now I'm on letter B, same page for you. So I'm doing 12 into 90. Now I didn't say it above, but I'll say it here. Technically speaking, this is 90 over 12. Remember I said your bottom number goes on the outside, right? And your top number goes on the inside. It's consistent. Okay, so 12 does not go into 9, but it goes into 90 7 times. Take note, I am above the 0, not the 9. 12 times 7 is 84. I subtract and I get 6. Well, 12 doesn't go into 6, and I can't leave a remainder right now. So I'm going to add my decimal point and I'm going to bring it up. Sorry, that's a decimal. Let me erase because I don't want it to confuse anybody. Okay. All right, so I add my 0, I bring it down, I have my 0, right? So 12 goes into 60 5 times evenly. 5 times 12 is 60. I subtract and I get 0. So my answer is 7.5. Okay, couple more. So we're going to use long division. We're going to do A, B, and D. Okay, so for A, we're on page 74. I set you up 4 into 5. So they're saying, we're showing how 5 divided by 4 or 5 over 4 is, and they already gave us an answer, right? We know the answer should be that, but we're proving why. So this one is 4 into 5. So 4 does go into 5 once, and we put 4, we subtract, and we get 1. Well, 4 doesn't go into 1. So I need to put my decimal and put my decimal. Okay, let me fix that. It's hard to make a decimal with my little pen here. There we go. I use my finger instead. Okay, so, and then I'm going to add a 0. I'm going to bring it down and I get my 0, right? Well, 4 goes into 10 2 times. 2 times 4 is 8. When I subtract, I get 2. Well, I still have a remainder. I need to keep going. So I need to add a 0. I need to bring it down and I get 20. Well, 4 goes into 20 5 times. 5 times 4 is 20. And I get a 0. So this one is 1.25. Okay, so now they flipped it, kind of like what I did in the beginning. Now we're doing, we'll describe why 4 divided by 5 is 0.8. Okay, well, 5 goes into 4. It doesn't, right? So I add my decimal, and then I bring it up, right? And then I add my 0, right? So 5 goes into 40 8 times. Take note that I'm to the right of the decimal. I am doing 5 into 40, not 5 into 4. Okay, well, 8 times 5, that's 40. You get a 0. So your answer is 0.8, or what some of you like to do, 0.8. These are equal. Whichever way you write it is correct. All right, last one that we're working out here. Number 3, and I'm jumping to D. So please make sure you're writing under letter D. Okay, we're doing y is 1 divided by 25, 0.04. Okay, so 25 does not go into 1. Okay, so I'm going to automatically put my little decimal here, and I'm going to put my little decimal up at the top, right? And I'm going to add a 0. Well, does 25 go into 10? Not really, right? So let me kind of work this out just from the beginning, right? So 25 goes into 1 0 times, right? It doesn't go in. 0 times 25 is 0, right? We subtract and we get a 1. We bring down this 0 that I added. Okay, well, 25 doesn't even go into 10. So that's also a 0. Right? So now I'm going to add another 0, and I'm going to bring it down. Well, I know 25 goes into 100 4 times. 4 times 25 is 100. And I end up at 0. So your answer could be 0.04, or it can be 0.04. Okay, so last little bit here. Noah said, we cannot use long division to calculate 10 divided by 3 because there will always be a remainder. What do you think he meant by there will always be a remainder? Well, here's what I wrote. I wrote for A, 3 3s in 10 with a remainder of 1. That's what he means. 3 goes into 10 3 times, but there's going to be something left over, which is that remainder 1. Do you agree with him? Your answer should be yes. So please copy that down. Please make sure that you copied all of the ones that I worked out for your notes, and enjoy the meet and turn in your notes.